7.4, matrices and system of equations. What we should learn: write matrices and identify the dimensions, perform elimination row operations on matrices, use matrices and Gauss elimination to solve linear equations, and use matrices with Gauss-Jordan elimination to solve linear equations. First, let's talk about a matrix. A matrix is a collection of data that's arranged in rows. This is a matrix. And we use it to streamline techniques of solving system linear equations. So we're going to be able to use a calculator or computer to solve linear equations using a matrix. This is what a matrix is. We call a matrix n by n. We go row by column. That's the size of the matrix. Here, we have rows 1, 2, 3, 4. Rows will go this way. These are our rows. And our columns go up and down. And the number of rows you have, the number of columns you have, we'll call it an n by n matrix. And each value here is an entry in the matrix. The dimension of matrix is row by column. That's how big the matrix is, row by column. Let's look at dimensions of these matrices. This first one, there's one row and one column. This is a 1 by 1. Over here we have one row, row 1, but we have 3 columns, 4 columns actually. This will be a 1 by 4. Here we have a 2 by 2. There's 2 rows and 2 columns. Here we have 3 rows, 1, 2, and 3, and then we have 2 columns. Row 1, row 2, row 3, column 1, column 2. This is a 3 by 2, and this will be a 3 by 1. That's the dimension of a matrix. It's rows, then columns is the key. Dimensions, rows by columns. We can use matrices to solve system of linear equations. First, we need to rewrite the system as an augmented matrix. Let's say we have a system of linear equations, then we can rewrite it as an augmented matrix. The general rule here is your x is going to be your first column. Each system is going to be a row. Your x's should go in the first column, your y should go in the second column, your c is in the third column. And we'll put a line here to differentiate what our solutions are, what they're equal to, right there, row by column. And again, the elements in here are called elements. This is a 3 by 4 matrix, and how are we going to solve it once we have it in the matrix? There's some row transformations we can do. We can exchange any 2 rows. We can switch any 2 rows we want. We can multiply any row by any non-zero number. You can multiply row by number, and you can multiply any row by number, and then add it to another row and change that to a new row. I could add these 2 rows up and make my new row too. That's the idea there. So we're going to do some of those elementary row operations. What do we want to get? We want to get what's called row echelon form. That's the thing here where we have 3 zeros. What that does, it makes it really easy to solve for x, y, and z. Because in this case, remember this is x, y, and z. And this one, I know my z equals 4. And once you have that, you can just back substitute. You go, okay, like we did with 3 by 3. Z equals 4, plug it into this equation, solve for x, and then get those, plug it into the top equation, and get your y. That's called row echelon form. And eventually, when I go to what's called reduced row echelon form, which is, you see the zeros here, we also mirror it with the zeros on this corner. Once you get to here, z equals -2, y equals 4, and x equals 1. Reduced row echelon form makes it really easy once you get to there. Now, getting to there by hand is a little work. And you can also see how it's done on a 2 by 2. The 2 by 2 here, oh, my negative y equals 2. You can use that to solve for x. Over here, you just go, y equals 4, x equals 3. That's an example. We're going to solve this by using augmented matrices. First, let's put it in an augmented matrix. Look like this. Row 1 can go 2, -4, line for the equal sign, and 8. And the bottom rows will go 1, 1, and -2. Now watch out, it's very easy to forget the negative. Actually, I did this once and I forgot the -2 and I had to go back and restart my video. We have that. And now we want to get this guy to be a 0 here. Lots of ways you can do this. Even if you notice, this top row is all even. If you want, you can do something. Let's multiply row 1 by 1/2 and make it a new row 1. That's one of the elementary row operations we could do. We could always just multiply any row by any number, and that's non-zero. That makes it a little easier. And now I want to make this guy a 0. Let's do row 1 plus -1 row 2. Let's try this. Row 1 plus -1 times row 2. We'll put that in row 2. You can multiply row by number, add it to another row, and put that in for any row you want. So first, let's multiply row 2 by -1. That becomes -1, -1, and 2. Then let's add these 2 rows up. I'm going to get, keep in mind, row 1 to say exactly the same. Let me write it down so I don't forget. Row 2 is going to change. We're going to add these 2 up and get 0, -3, and 6. And then there we go. We have row echelon form. Using this, we can back substitute. This lets me know that -3y equals 6. And then here we have x minus 2y equals 4. We can solve this real quick. Divide by -3. Y equals -2. Then we go back and substitute that in there. X minus 2 times -2 equals 4. X plus 4 equals 4 minus 4 minus 4. X equals 0. We have 0 and -2. That's how we use row echelon form and matrices to solve the system of equations. Let's try another one now that we have the hang of it. This is going to be 5, 2, 1, 2, -1, and 4. Our primary goal is to get this to be a 0 right there. In this case, I really can't multiply. I can't just multiply this by a number to make them cancel out there. You know, oh, I can cancel the y's. But we're trying to do row echelon form. We're trying to make this guy 0. So it looks like I have to do row 1 times 2 plus -5 row 2. And we'll put that to ugly -5. Put that in row 2. We're going to do something like this. We want to make this a 0. I need to find the common denominator. Let's multiply row 1 by 2. I'll do this up here. 10, 5, 4, and 2. And then we're going to multiply row 2 by -5, -10, +5, and -20. Again, very easy to make a small mistake. Keep in mind, I'm keeping row 1 exactly the same. I'm only going to change row 2. I'm going to copy down row 1. And then row 2, we're going to add these up. I'm going to get 0, 9, and then this is -18. If I want a proper row echelon form, you generally want this to be a 1, and you want that to be a 1. Now, in this case, we just multiply each row by 1 over 5. You get proper row echelon form. But once you get down here, I generally just solve it. Okay, I know this is 9y equals -18. Divide by 9, divide by 9. Y equals -2. And then you plug that back into the top row. You get 5x plus 2 times -2 equals 1. 5x minus 4 equals 1. Plus 4 plus 4. 5x equals 5. Divide by 5. X equals 1. We have the point 1 and -2 as our answer. Like that. That's how we could use row echelon forms to help solve a system of equations. And like I said before, if you wanted to see something that's a little more proper, you could do 1/5 times row 1, make that row 1. And I could do 1/9 row 2 and make that a new row 2. If we had done that, I would have got 1 2/5, 1/5, 0, 1, and -2. This is more proper row echelon form. And then here you know, oh, y equals -2, done. And you have to go back and plug it in here to find out what your x is. Works either way. How about let's do it with the 3 by 3. First, we can pretty much do the same way. Let's put it in augmented matrix form. 1, 3, 5, line 2, 0. There's no x, so we'll put a 0 there. 1, 2, 3, 1, -1, -2, and 4. If we're trying to go row echelon form, I need these guys to be a 0. Luckily, we already have 1 0. The next thing we do is try to make this guy a 0. What we're going to do is work with things that have numbers left. Don't mess with the 0 here. Work with this one and this one to try to make this guy a 0. I'm going to do row 1 plus -1 row 3 and make that my new row 3. I'm going to try to make this guy a 0 here. I'll multiply row 3 by -1. So -1, 1, 2, and -4. Now again, when I do this, we're going to keep row 1 and 2 exactly the way it is. 1, 3, 5, 2, 0, 1, 2, 3. And now we're going to add row 1 plus -1 times row 3. So I add 1 with the blue here. I get 0, 4, 7, and -2. Again, very easy to make a small mistake. 5 plus 2 is 7. 2 plus -4 is -2. We have this system. Now if I'm trying to get row echelon form, I want this guy to be 0 next. So now I'm not going to deal with row 1 anymore, because if I do with row 1, I'm going to add the 1 to some of these. I don't want that. I'm going to deal with these two. Deal with the two ones that have a 0 here. So let's multiply row 2 by -4 and then add it to row 3. So I'm going to do -4 times row 2 plus row 3, and that's going to be my new row 3. Let's write out what we have still. I'm not going to change row 1 and row 2. I'm only going to change row 3. Let's do this operation now. So -4 times row 2. Let's multiply row 2 by -4. It's 0, -4, -8, -12. Now let's complete this operation here. I'm going to add -4 times the -4 row 2, which is in red, plus my row 3. So I get 0, 0, -1, and -14. That's essentially row echelon form, but this should be positive. So let's actually just do that real quick. I'm going to multiply row 3 by -1. I'm just going to get 1, 3, 5, 2, 0, 1, 2, 3, and then 0, 0, 1, 14. So then that. And now we can solve things. This tells me that z equals 14. Nice and easy. Then we go back to it into row 2, and that gives me y plus 2 times 14 equals 3. Y plus 28 equals 3. Y equals -25. And then we can plug both of those in to row 1 to solve those. We're going to get x plus 3 times -25 plus 5 times 14 equals 2. Now, 3 times -25 is -75. 5 times 14 is 70. So we get x minus 5 equals 2. Plus 5 plus 5. X equals 7. Which makes our solution 7, -25, and then 14. X, Y, Z. That's how we can solve the linear equation using matrices and elementary row operations. Since they are linear equations, we have two special cases. We can either have no solution or infinitely many solutions, Right here, you can see from the bottom row that you essentially have 0 equals 0, which is a true statement, infinitely many. And on this one, at the bottom here, you get 0z equals 9, which is basically 0 equals 9. That's false, and no solution. So just like when you solve the linear equations normally. If you get a true statement, infinitely many. If you get a false statement, no solution. Okay, now the real power of system matrices is that you could use your calculator or your computer to use Gauss-Jordan elimination. That's a way of getting the reduced row echelon form. But I'm going to show you how to do that next. How to use reduced row echelon form to solve a system of linear equations super easily. I'll bring out a calculator and we're going to solve the equation we just did, but with the calculator. I'm going to bring out mine. Let me clear this real quick. First, I got to go to matrices. So it's right here in matrix in blue. I'm going to hit second matrix. This is where you select your matrices. Right here. Now there's nothing, I didn't plug any in, so there's nothing here. Math, where you do some operations like reduce row echelon form. And then edits, where you type in our matrix. We go there first. We want to type in this big matrix here. First, you got to tell it what type of matrix, what's the dimensions of it. We have 3 rows and 4 columns because it's an augmented. We'll put say 3 by 4, and it'll build to 3 by 4. And then we just got to type it in. It's going to be 1, 3, 5, 2, 0, 1, 2, 3, and then 1, -1, -2, and 4. So it's all typed in. I'm going to hit quit to get out of it. Now if I go back to matrix, you'll see that the matrix we typed in is right there, to 3 by 4. Now let's go, there's 2 row echelon forms we could do. There's row echelon form, which gives us almost to the answer. Do a little work afterwards. And there's reduced row echelon form, which gives us the answer perfectly. So let's show how you do both of them on the calculator. In reality, we're only ever going to do reduced row echelon form, but just, knowledge. Under math, so let's get out here, just recap. I'm going to go to matrix. I already have my matrix typed in. I'm going to go to math. Toward the very bottom, you keep on going until you get to the bottom. We have REF, which is row echelon form, and we have RREF, reduced row echelon form. So let me show you row echelon form first. We have that, then we're going to select our matrix. We're going to do row echelon form on A. We're going to get this. And that pretty much matches this guy. And then let's go, what we're actually going to use is we're going to go back to our matrix, go to math, go to RREF. I went up to go a little faster. Then we go to our matrix, and we get our answer. 7, -25, and 14. That's the easiest way to solve a system of linear equations, is to use your calculator, make a big old augmented matrix out of it, solve it using reduced row echelon form. Now you know the secret.